broken thing, and we have this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Your feels better. Okay.
Hi guys, can somebody tell me if you could hear me?
Yeah, I can hear you.
Okay, good. I just realized I had my computer on mute, so that's why I didn't hear you guys before. All right, I'm just going to give everyone a few more minutes to get on, and then we will get started.
Dun, dun. Dun, dun. Dun, dun. Ha, ha. Hey, Mom,
Yeah, honey.
look at this. Mama, my Blockaby is doing yoga. And my wizard's doing yoga. Look, my wizard's doing yoga too. This is the part of yoga.
So if you guys are just joining, we're just going to give everyone another minute or two to join.
This is the part of yoga.
And then we'll get started. So I'm just opening up the worksheet right now. Boys.
This is a part of the yoga toy. Standing on your legs. You know that my wizard's taller. My wizard's taller. Stop it. You can stand on his tail.
All right, this might be it. So what I'm going to do is I'm actually going to go question by question, so that way you guys make sure you can check your answers to make sure you did it correctly. For as long as you submitted, please go away. As long as you submitted your work, you'll get full credit for it, whether it was correct or not correct. So this is really to help you make sure that you knew how to do the work and be ready for the test. So if at any point you guys have a question, feel free to ask the question. You can wait until the end if you want, but it might be better just to ask questions as we go, as you come up with them. All right. Before I start, does anybody have a question? I know 4 and 9 were tricky for most people. We're good? All right, so I just want to point out, work is an easy triangle equation. So we have work, which is measured in joules. So work and energy are actually the same thing because you need the energy to do work and you're using energy to do work. So they are actually considered the same thing. So if you notice down here with energy, which is at the top of the triangle, that is also measured in joules. Just writing some notes down to make sure I go over everything. So power, the difference between work and power is that power is how much work is done in a certain amount of time. So it's the same thing. We're still using our work, but then we're dividing it by time. Okay, so does anybody have questions before we get started? All right, so this first one, it says calculate the work, so we know that it's a work problem. I'm just gonna highlight that so we can point it out. So we are gonna use that first equation where force times distance is equal to work. So remember with a triangle, if they're next to each other, that's multiply. If it's on top, then it would be divide. So because it's asking how much work is done, that's what we're solving for, which means the two numbers that are going to be given to us are the force and distance. So work equals force times distance. And we have 50 newtons force, whoops. Clicking all the wrong thing, sorry, is your force, and we are multiplying that by 0.25 meters. The calculator out. And the answer would be 12.5. So remember, for this, units, we need to use units in science. So newtons times meters is joules. And the way I like to remember joules or work is that you do a lot of work to buy yourself joules. So hopefully that kind of like helps you remember when you're supposed to be using joules. So you need energy, or you do work, and you can buy yourself joules. So that's where the joules comes from. So we have joules. Did anybody get anything different than this that needs me to explain it again? All right, I'm moving on. I just want to check really quick again, make sure everybody can hear me. So can somebody just tell me they can hear me? Anybody?
I can hear you.
Okay, all right.
Wait, hold on. Miss Addison,
Yeah.
I just want to ask, are you going over the same thing tomorrow and Tuesday?
I'm gonna do the same thing tomorrow. So if you have questions tomorrow, you can ask. So you don't have to join in. Is that what you're asking? You don't have to join in tomorrow if you are saying today.
Yeah, I wanted to both days. Like, it's the same thing. I'm doing tomorrow.
You're cutting out. I didn't hear most of what you said. Could you, let's see. Well, if it's not that you just don't want to participate tomorrow because we're already doing it today, that's totally fine. But if you have a question, you text me with the Reminds app, or if you want to send me an email later. I just won't be able to email right now while we're on here.
Okay.
All right, so this is another one. Calculate the work done by 2.5 Newton force, pushing a sandwich across the table 0.5 meters. So it's the same equation as up here. And our work is going to be 2.5 newtons. And we're going to multiply that by 0.5 meters. And I get let me just double check, 2.5 times 0.5. I got something else. Yeah, 1.25. All right, so it's 1.25. And again, Newton times meter is measured in joules. All right, so this one, if a small motor does, now we have how much work is being done. So we have a division problem. So this one, we have work is given to us. And we're moving a toy car 250 meters. So that would be our distance. The question is, what force does it exert? So our answer for force, remember, is measured in newtons. So our answer is going to be measured in newtons. So it's going to be work divided by meters is distance equals force. All right, so work, we have 600 joules divided by 250 meters. And we get 2.4 newtons. All right, anybody have any questions on 2 or 3? All right, 4. So 4 was one of the trick ones that you guys had. If you watched the videos that I posted, you would have kind of found the trick to this, but we are going to do the math part of it too. So this is saying that a 70-kilogram man pushes 5 times 10 to the 5th ton wall for 300 seconds. Hold on. Boys, quiet. But it does not move. So how much work is done? So this is asking work. So work, remember the equation is work times, work is equal to force times distance. Okay, so we don't know what work is yet, but the force is, so this is how much he weighs, not what his force is. And he's pushing on how much the wall weighs, but not what his force is. But it's by 3, he pushes it for 300 seconds, and we don't need to know time for here because that would be power. But the trick is that it does not move. So force is still a question. We don't know because it's not given to us. But if it does not move, it would be 0 meters. So anything times 0 would equal 0. So even though this question doesn't give you enough to be able to try to solve for it, it doesn't matter because if it does not move, there is 0 work being done. So once you notice that it says it does not move in any of your questions, you know right away that work has to be 0. Do you guys get that? Anybody have questions on that one? All right. 9 was similar to that one. The person was pushing down on a box, and again, it didn't move. It didn't say it didn't move, but if you're pushing down, it's not going to go anywhere. So if a man kicks a soccer ball doing 2,000 joules of work, 2,000 joules of work, and a force of 100 newtons. So remember, work is on the top, so it's going to be divided by 100 newtons. Oh, it would be 20. Oops, not 20 joules, sorry. 20 meters would be what it would go. So I'm just going to write the equation above that in case you guys need to look at that again. So it would be work divided by force equals distance. So if you look up here again at the triangle, work divided by the force, so one on top of the other would equal the distance, what we're looking for. All right, how much power? So we're getting into power questions now. How much power does it take to lift 20 newtons, 10 meters high in 3 seconds? So this one's a little bit tricky. We need to use that work because we need to figure out what work is, and then we need to divide it by the time for power. So let's just look at the power equation again really quick. So work is, what's the question again? How much power does it take to lift 20 newtons? So newtons is our force, 10 meters high is our distance, and 3 seconds is our time. So we have force and distance. So we would multiply those together to get the work, which would go here. And then we would divide that number by the seconds. Does anybody have questions with that? Do you guys see how that would work? Because joules, the work in joules is the same as the joules in energy. So once we have the joules, we'd be able to divide it by the time. So we're multiplying the force times distance first. Force times distance equals work. And then work divided by time would equal power. All right, so this one, force times distance, we have 20 newtons times 10 meters equals 200 joules. So then we're going to take these 200 joules divided by 3 seconds equals 6 point, let me just double check if that's right. So we have 66 point, it's 6 repeating, so I'm just going to write 6, 7. And that would be our power, which is measured in watts. Now, don't get confused. We have work, which is measured in joules, and we have watts, where power is measured in watts. So there's two W's here, so that can be a little bit confusing. So just make sure that you're understanding that the W down here is watts. So if it helps, I would just spell out the word watts so you're not confusing it with work. All right, so this one, you move a 30 Newton object 5 meters. How much work did you do? So again, it's asking for work. Work is on the top, so we're going to take those two numbers and multiply them. So we have 30 newtons times 5 meters equals 150 joules. All right, so I'm just going to go back through force times distance equals work for the equation. All right, so you carry 25 Newton bag of dog food up 5 meter flight of stairs. How much work was done? So this is another work problem. And work is equal to force times distance. So work is what we're solving for, equals our force is, it's going to be a force pushing down, so it's 25 Newton bag of food times 5 meter flight that we're going up equals 125. Joules. All right, any questions 1 through 8? Are we all good so far? All right. All right, so now here's that other trick question that I was saying. So if you're pushing down on a 10 Newton box for 10 minutes, if you're pushing directly down into the floor, it's not, we are assuming it's not moving anywhere. So we can still do the calculation. So remember how much work is done. And I'm also going to pushing down. I'm going to highlight, sorry, pushing down. So we have work is equal to force times distance. Work equals, force would be our 10 newtons times 10 minutes, but distance is going to be 0 meters. So anytime you multiply by 0, you get 0 joules. So no work was done. All right, that was the most, number 4 and number 9 were the ones that tricked most people. Do we all see how number 9 works? Does anybody have questions on that one? All right, moving on. Okay, so you use 45 joules of energy to move 9 Newton object. How far did you move it? So now we're talking about energy. Well, we want distance here. So how far did you move it? So if you go up, if we're looking for distance, the only one that has distance is going to be this one. So this is going to be our equation, even though we're not talking about the word, we're not using the word work, we're using the word energy. So don't confuse that, because remember I said they're interchangeable. So we're going back down. So we want to know distance, which is distance is equal to work or energy divided by force. I'm just going to go over here. Work, it's the same thing as saying, I'm going to use the letter E for energy, divided by force. So it's the same thing. So we have distance equals our 45 joules divided by the force is 9 newtons. So 45 divided by 9 is 5, so it equals 5. And joules divided by newtons would be left, we'd be left with meters. We're talking about distance. Normally I would show you how to cross all the units out, but for it's a little complicated showing you guys on the computer. So just remember that to get joules, it's Newton times meter. So when you divide a Newton, you're taking away a Newton and you're left with just a meter. All right, so number 11. How you do 55 joules of work in 5 seconds. How much power? This is a power question. So if you remember, power is on the bottom. Power is down here. So joules is given to us and the time is given to us, and we're trying to calculate power. So joules or divided by seconds is what the equation is going to be. So power equals energy or work divided by, actually this one uses work, divided by time. So the power equals 55 joules divided by 5 seconds, which would equal 11. Now we're looking for power, and power is measured in watts. So again, to not confuse the W for work with the W for watts, I'm just going to spell out the word watts. Okay, and the last question. We have a car uses 2,000 joules in 25 seconds. What's the power? So again, we're looking for power, which is the same equation as up here. And we have 2,000 joules divided by our time would be 25 seconds. That should be capital. Oops, sorry. Equals, well done. 80, and we're looking for power, which again would be in watts. So 80 watts. All right, so that is all of the equations, and your test is extremely similar. It is pretty much the same questions with different numbers. So if you guys have any questions with any of them, hang around and you guys can ask me, or you can email me, but it would probably be better to ask me now so I can show you. So if you guys completely get it, the rest of this week, what you're going to be doing is a test, which is already posted on Google Classroom. And then you're also going, so that's up here, so that's due on Wednesday. And then you're also going to, I'm going to post this on Wednesday so I make sure that you guys are focused on the test. You're going to do this one, Simple Machine Research Notes. So I'm just going to open that up so I can show you guys really quick, and then you guys can ask me the questions, the calculation questions if you have any. All right, so we're talking about simple machines, which is where the work and power came back from. So you're just going to answer, use the internet to answer these questions. What's a simple machine? What's its mechanical advantage? And then you're going to play this game. I had my 6-year-old playing it yesterday, and he actually this morning asked if he could play it again. So we need Adobe Flash Player. I'm pretty sure your computers have that. I'm hoping. So let me know if for some reason you can't open it. And it tells you step by step. The only thing is I got a little stumped. Okay, so once you click on the first one, it says incline plane. I just didn't notice this start down here for a while, so I just had him like walking around, following the strawberry, and then I realized there's a start there. So you need to click on the start in order to actually get to what you need to do. So I'm going to close that out. You should be able to even play it on your phone if you want to play on your phone. Okay, so you're going to use this, and then once you go through the whole incline plane, you're going to find a picture of an incline plane to insert here. And then these 4 questions you'll be able to answer as soon as you're done with the simulation. Once he does the work, then these questions, not the questions, but the answers pop up. So you're just literally copying word for word what they already have written for you. So that game only has 4 of the 6 simple machines. So we have the inclined plane, lever, wheel and axle, pulley. And then the other 2, you're going to find pictures for again, and then just explain, use the internet to explain what is a screw and how can you increase the mechanical advantage. Same thing with a wedge. What's a wedge and how do you increase the mechanical advantage? All right, so does anybody have questions on the rest of this week's work? All right. Does anybody have questions on the calculations now then?
Could you redo 9?
Okay. So 9. Oh, that's the wrong one. Let me go back to the answer one. All right. So 9, you are pushing down. So think, if you're pushing down on something, it's not going to move. So the distance would be 0, right? And you're giving a 10 Newton force for 10 minutes. But the question is about work, not about power. So this 10 minutes, we don't need. So the equation is going to be work equals force times distance. The force is going to be 10 newtons. But the distance, because we're just pushing down and it's not going anywhere, is going to be 0 meters. So anytime you multiply by 0, you're going to get 0 joules. So anytime there's a question that it says it cannot move, just like number 4, it said it did not move, then your answer is going to be 0.
Oh, okay, I get it now.
Okay, good. Anybody have any other questions?
I have a question.
Okay.
What was the other one that was like, it was after 9, but I think it was like 11, or yeah, I think it was 11.
The power question?
Yeah.
Are you sure it was the one after 9?
Yeah.
After 9 and not, or maybe was it number 10?
Yeah, I think it was number 10.
So 10 is the one where it's saying that you use 45 joules of energy to move a 9 Newton object. How far did it move? So since we're talking about distance, the equation that you would use, I'm just going to go back up to the top. The equation you would use would be this one. So even though it says energy, if you notice, energy down here is measured in joules and work is measured in joules. So you need energy in order to do work, and you do work using energy. So they're measured in the same thing, so they're interchangeable. So even though it says energy, it's still this equation that you would use. I'm going to post this also so you can double check, but I'm just going to go back down. So this is the equation that is given to you, and the 45 joules of energy is what the question says, but because you can interchange energy and work, this is the equation that we use. So distance is equal to energy divided by force. And then here's our energy, here's our force, and then this would be the distance.
Okay.
Any other questions?
Thank you.
You're welcome. The only other like kind of tricky one, other than like the 2 trick problems with number 4 and 9, was the 2-step one, which was, I think, the 3rd one. Oh, no. Where is it? This one. So number 6 was the only other tricky one. So I'm going to go over that again for you guys really quick. So how much power does it take to lift 20 newtons, 10 meters high in 3 seconds? So we had to have 2 parts. So first we had to find the work, because remember, power is equal to work divided by time. So first we had to solve for work, which would be multiplying these 2 numbers together. So our force and our distance, which down here would have given us 200 joules. And then now that we have work, we can divide work by time to figure out what the power was. So we would take our 200 joules and divide that by our time, 3 seconds, and we get 66 point. It's 6 repeating, so I just rounded up 6-7, and then watts. All right, does anybody else have any questions? All right, so I would recommend, if you guys did a good job on the work and power problems on your own, and now you completely understand this, I would recommend going on right now and opening up your test and completing it. So then you have a few days free. I am posting this the work one tomorrow, not right on Wednesday, but I just took because I just wanted to give you guys one day to really focus on the test part. So if you guys have any questions, ask now. If not, I would go finish the test, and then you guys are done with science for a couple days. All right, any other questions? Last chance.
Nope, these were actually pretty easy.
Good. I tried to make them. I took out any of the really challenging. Well, not that any of them are really that challenging, but I tried to make it so that it was very obvious what it was asking. And like I said, the test is exactly the same, just with different numbers. So just don't be tricked on. Don't look at the questions and think, oh, we just did this, and copy the answers, because you'll be wrong. All right. So have a good week, guys. And if you do have any questions, feel free to email me or text me through Remind. And that's it. All right. Have a good day, guys.
Bye.
Bye.